Let's take a look at standard IF.7. In this standard, it says that we need to be able to analyze functions using different representations. So question number 1 says, over which interval is the function f of x equal to 2 minus x to the 4th plus x to the 5th positive? So I'm definitely going to type this into Desmos to take a look at what is happening, but I'm just going to type it the way it looks. I'm not going to worry about putting it in standard form because that is not necessary. So I see my function and it says over which interval is it positive. So positive, let's review, is above the x-axis. So anything above the x-axis is considered positive and anything below the x-axis is considered negative. And right on the x-axis is neither. So I see right at -1, it's touching the x-axis. So it looks kind of like this is at -1. So -1 itself would not be positive, it's neutral. So I want the one with the parentheses because -1 would not be included in the interval that's positive. But then everything above that, so as x goes to the right, that's why it says -1 to infinity, because it's going from left to right. And that would be our interval that is positive, because the bracket would be wrong, because that would mean that -1 is positive and it's right at the x-axis, so it's neither. And then the ones with the 0 are just incorrect, because that's not where that interval starts. Or that's the y value where it starts. So I know where they're getting that from. But you want to pick out the x values. Whenever they say the word interval, you're thinking of left to right, what's happening to my x values. Okay, so question number 2 says, given the function f of x equals the absolute value of x minus 5 plus 7, which choice shows an interval? So again, when they say interval, think x, and think left to right, what is happening in this area of my graph. Which choice shows an interval of the domain in which the f of x is only increasing? So increasing is left to right, you're going up instead of down. So let's type it in and take a look. We got the absolute value of x minus 5 plus 7. So I see it's going down, and then it turns around and goes back up. Like if my car was driving along from the left to the right, it goes down, but then it turns around, and this would be the increasing interval that starts at 5 and goes to infinity because it's going to the right. So we look over here at our options. Right at 5, it's not doing either. That's the turning point. So A looks most appropriate. Now let's look at number 3. A function is shown. Which of the following statements describes the end behavior of this function? So again, let's type this in Desmos and take a look. So we have 1 minus 2x divided by x minus 4. So I'm just going to draw a quick sketch of what's happening. So let's see, it goes here. Actually, I drew that wrong. Let me fix it. It goes below the x-axis. So let's pick out a few things, and that'll help me draw a better picture, because I can see that there's a restriction in the denominator, which makes it my vertical asymptote will be at x equals 4, because that's the restricted value from my denominator. And when I type in x equals 4, it should look like it lines up with my graph. So that'll help me make a little better sketch on my paper. So at x equals 4, there's a vertical asymptote. And the horizontal asymptote goes with my degree. So if I reorganize this so that it's in standard form, I would put negative 2x plus 1 in my numerator to rearrange these two terms. And then x minus 4 is in the denominator. Then I see I have the same degree on the top and the bottom. And so my horizontal asymptote would be y equals negative 2. And I can check it because I can just type that in over here and make sure that it lines up with my graph, and it does. So I've got a nice horizontal asymptote at negative 2. And then I can make a better sketch of this graph a little easier. So I have this little branch right there and another little branch over here. And that'll help me when I try to pick out this end behavior now. So it says, As x goes toward positive infinity, so that's talking about this end of the graph, what is happening? X is going to the right. Is y approaching 4? So it looks like the y is approaching -2, because that's what y is up to right there. It won't go any higher than that. It's just going to -2. But then that's not an option. It only has a +2 as an option. So neither one of those would be right. So C says as x goes toward negative infinity. So that's over here on this side of the graph. And it looks like y is approaching -2. So they gave us that option this time. So C is correct for that one. Question number 3, which I think this is actually question number 4. So let's renumber that. Question number 4 says, what is the set of x values for which the function f of x is discontinuous? That means it's not defined, or it has a hole in the graph, or it has an asymptote. So for this one, we can type it in and we can work it out with factoring. So I'm going to do both. That way I can check my answers in just a minute, and I'll make sure I have them right. So what I would do is type that in like I did, and then let's factor this out and see what's going on. So I need to multiply to get 6 and add up to -5. So multiply to get 6 and add up to get -5. So I know 1 times 6 would give me 6, but that would add up to a positive number. So I need to make these negative so they add up to a negative number, but then they would add up to -7. So then they don't help. And then I have, let's see, -2 times -3, and they would add up to -5. So those are the ones I need for my factors. So let's put x minus 2, x minus 3 at the top. And at the bottom, we need to multiply to get 2 and add up to get -3. So I got to multiply to get 2, and I got to add up to get -3. I'm just going to continue my chart here. So 2 only comes from 2 things. It can come from 1 times 2, or it can come from -1 times -2. So I definitely need the negatives so that they'll add up to -3. So let's put x minus 1 and x, and I put that wrong down here. Let me fix that to be plus -2, x minus 2. So then I see that I have a couple things going on. I've got a hole in my graph at 2. Let me get my pen. There's a hole where the factors that cancel out would equal 0. So these equal 0 at +2. So there's a hole at x equals 2. So that's a discontinuity, or it's discontinuous at x equals 2. But it's also going to be discontinuous at x equals 1, because that's the vertical asymptote. That's where this part of my denominator would equal 0, because x can't equal 1. That creates a discontinuous part of my graph as well. So we can check both of those over here. We can type in x equals 1, and we can see that that is where the vertical asymptote is. And we can see that we have a hole in our graph at 2, because it's undefined at 2 and it's undefined at 1. So when we look over here, we could also check 3 with our table real quick, but notice 3 is fine. So I see I have 1 and 2 are option C. All right, so I think that is it for standard IF.7.